I'll be talking about propAMMs. They have been fairly trendy last months. So brief overview, quick background on 0x. This is where I work. And a quick background on DEX aggregation, because this is what we do and everyone is using it, whether the people know about this or not. And then I'll talk about propAMMs, why they're good, why they're bad, what's ugly about them. They show up in like all three categories here. And this is loosely based on an article that we published recently about propAMM shenanigans. This is work of more people at 0x, so it's like not purely my research. Many people are involved at our company. We look at this stuff quite regularly, check how transactions settle, what's going on. So if you want to read an in-depth research article about this, I encourage you to look at this blog post. Right, so yeah, quick introduction about 0x. We've been building DEX infrastructure since 2017. It's almost a decade at this point. We were the literally first DEX protocol on Ethereum. Before Uniswap or all of that stuff existed, there was 0x. It was a mechanism of matching off-chain orders and on-chain settlement. This has been retired many years ago now. We were involved in quite a few major EIPs on Ethereum. The final WETH design, EIP 712, which is type data. Everyone uses it these days. And we also designed the NFTs. We even managed to remove them from our protocol before they gained traction. But yeah, EIP 721, the NFTs is basically a brainchild of 0x engineers. We're also the first protocol that internalized MEV using priority gas auctions. That was also many years ago, has been retired since. But we kind of always front run the trends. Many things that are happening right now or have been happening, we already thought about it, implemented it, and yeah, we're always on the forefront of on-chain innovation. At 0x, we support a vast ecosystem. I think now it's even more than 19 chains at this point, hundreds of liquidity sources. We do DEX aggregation these days, which is basically figuring out how to swap tokens. Someone wants to swap token X to token Y, and we find you the route. So we have an API, 0x API. You can use it. There are other products like this, and this is our core offering. We also have cross-chain API. We have gasless APIs, whole suite of APIs for basically on-chain trading. Whatever you need to do, we have a product for this. So I mentioned that we do DEX aggregation. So the issue is as follows. Like when you want to swap, I don't know, ETH to USDC, there are many venues where you can swap ETH to USDC. The price is not the same on all of them, but typically the best order or like the best result you'll get not by going to a single venue, but spreading the transaction over a few pools. So here is a sample illustration. I mean, I just typed it on our UI on Matcha. There is a booth for Matcha. Check out. This is our swapping product. Like that's a random swap for 1,000 USDC to ETH on base. So this uses 5 liquidity sources. So what we do is we keep track of that stuff. We need to know about all the tokens that are out there and pools. Currently, I think on base we index around 100 million pools and even more tokens. This includes understanding both traditional AMMs, which are you might heard of like Uniswap, Curve, Balancer, also on-chain order books, RFQ. I'll talk a bit about RFQ later. ERC4626 protocols. That's just having a holistic understanding of all liquidity that's available on chain. And we need to know how to access it and how the liquidity curve looks for every single pool in order to produce the best route. And yeah, we keep track of that, our system. And we pre-process the inputs, and we solve an optimization problem. The optimization problem is, okay, I'm selling 10 ETH. What's the highest amount of USDC I can get out? And if you add gas to it, I mean, not all sources consume the same amount of gas. It might happen that one source gives you a better price, but it uses more gas. So in reality, it's not better. This creates a very interesting and difficult problem. It's both theoretically difficult and it's practically difficult because you need to index tens of millions of pools. And these routes that occur, they can get fairly complex. That's a real route. It happened on chain. It happened on a meta aggregator, meaning we beat all other aggregators with this route. And it jumps through 7 intermediate tokens, 8 intermediate tokens. It has like 20 swaps in it. And you can produce, they show up in real life, even routes that have 50 swaps. It's a very complex environment, and navigating it well is quite challenging. So I wanted to say a few words about RFQ, which is an abbreviation of request for quote. RFQ or private market makers, it's known under different names in the industry. So this is liquidity that's served by professional market makers, and it's a very old concept. First on-chain desks launched in 2020. I think we were the second desk. There was one that was before us. But unlike dexes, like your Uniswaps and balancers and curves, this is not publicly available. This has a pretty complicated off-chain component that we need to take care of as the DEX aggregator. So how this works? There is a market maker that has funds, and market maker also, I mean, someone wants to sell 10 ETH for USDC, and the market maker wants to participate in that trade. In order to do that, we need a mechanism to ask them for their pricing. So what makers do typically is they publish, we call it levels, but the shape of their order book, an approximation of their current understanding of liquidity, they publish it on our servers. You don't see that. And wherever you go, is it 1inch, is it 0x, is it Kyber, is it Velora, they have this. Like they have these market makers that are publishing indicative approximation of their liquidity. They live on our servers. You don't see them. We do the routing, we solve the problem, assuming this liquidity. And if a market maker, if their pricing was good enough to make it into the mix, we will try to include this market maker in the route. But in order to do that, they need to actually sign the quote. So the flow is, okay, your quote is good, now sign it, so the user can then execute it. And so the market maker signs the quote. This quote has a fixed price, and it has a deadline for UX purposes. It takes a while to click through the UI, confirm transaction, send transaction, and then get included, especially on a slow chain like Ethereum, where it's 12-second blocks. It can easily take 3 blocks for a transaction to land from quote to actual inclusion. So the market maker signs a firm quote for a fixed price, and they need to block these funds for next minute. This is not ideal for them, but it still offers often better pricing than your normal DEX. And since these quotes have deadlines, the maker has to sit on this price for a minute. Market can move in a second, so minute is quite a lot. And on slow chains, this is ripe for abuse. There are people who are requesting the quotes, sitting on them, checking whether the price changes on Binance, and if it changes on Binance, they will take the quote from the market maker and trade on Binance. It's very difficult to police this behavior. Like, we don't know if someone is asking us, if someone wants to sell ETH to USDC, we don't know who that person is. It's the beauty of DeFi. It can be anyone. One way to do this is to give the last look to the market makers. So market makers will sign, but they will sign first, then the user has to sign, and then the market maker at the last second can reject the quote if the market moved against them. But this is fairly difficult to implement well. And for many years, RFQ has been the major trading primitive on Ethereum. This is from 2023, and the orange is how much how much of our ETH to USDC volume that we move through 0x API is through market makers. So in its peak, it's been like 40 to almost 50%. So half of the volume is private liquidity. It's not DEXs. The time passed, and people came up with a new invention, which is called propAMMs, and this is what I'll be talking about for the rest of my talk. And this is a hybrid of a DEX and RFQ. I'll describe in a second how it works. And this is operated by the same market makers that provide RFQ quotes. They're closed source. You don't see the code. You don't know what their contracts do. And they move a ton of volume. And the variations of these, some mechanisms which are similar to how propAMMs work have been around for quite some time, but they really gained popularity on Solana last year. And this is a chart of how much showing how much volume on Solana on Sol to USDC is filled by propAMMs, and it's in high 80s. Basically, DEXs on Solana are non-competitive compared to propAMMs. And how they work. I will come back to EVM in a second, but I mean they were kind of born on Solana, so it's best to describe them using Solana as an example. So these propAMMs are run purely on-chain. For RFQ, there was this off-chain component where the market maker has been publishing levels on our servers. This is gone in propAMM. The market makers, they update their quotes on-chain. Everything lives on-chain. So the operators of these propAMMs, they try to land the transactions, updating the prices on-chain on every block, sometimes multiple times sometimes multiple times in a block. It depends on how the blocks are constructed. But on Solana has, I'll explain in a second, but Solana has 400 millisecond blocks. So even if you do it once per block, you have like a refresh every 400 milliseconds, while we update our levels every 500 milliseconds. So these are actually quotes you can set. I mean, this is liquidity you can settle against. There is no signature. There is no loop to get the signature. So this is clearly an improvement for the market maker. Also, market maker doesn't need to sit on the quote. So one very important component of this is that the price updates, these transactions that update the price of their liquidity, it has to be cheap. And Ethereum, for example, is not cheap. And Solana, in turn, is very cheap. And these updates are 1,000 times cheaper than actually swapping. They cost nothing. If you do this 24/7 on multiple markets, it costs some money to run. But in general, on Solana, you can run this very cheaply. If you are swapping a lot, it will offset the cost. And on Solana, you have these chunks which are emitted every 40 milliseconds. So in reality, you can update your prices every 40 milliseconds. This is much better than updating your prices every 12 seconds. And when the chain gets congested, on Solana, 20% of Solana transactions are propAMM updates, which is quite a lot. And they do 200 transactions per second. This is, again, this 200 transactions per second, this is only the propAMM updates. While on Ethereum, yeah, we do, I don't know how many transactions per second, but not too much. And there are different trade-offs between these models. It's a little high-level overview. The code for propAMMs is not open source. The liquidity provision is active. It's not LPing like in your normal DEX, but the market maker moves the price themselves. It's not publicly accessible. Everything is closed source. You need to be whitelisted to use it. You do not get firm quotes from them, meaning what you see right now will probably not be at not be the price you will settle at in 20 seconds or whenever your transaction actually hits the chain. And the source of truth is actually on-chain. It's not some off-chain signature and a promise that you'll verify later. And why they are so good? They do not sign anything. They do not need to commit any funds. They refresh the price as the time progresses. So they don't need to lock the funds. And the taker doesn't have the optionality to take or not take a signed order for a minute. They will manage to update the price many times from the quote until settlement. So they basically offload the volatility to the user. It's user's problem that they will not settle at the price that they saw, not the maker's problem. They don't need to hedge for this volatility, so spreads are much tighter. They are basically at the level of Binance. Your typical ETH USDC pool on Ethereum has 10 basis points spread, and they can quote at 2 basis points. There's no toxic flow. That's not true, but it's much harder to ARB them, so the spreads are tighter. Market maker typically need to widen the spread a bit to accommodate for toxic flow. And the problem is, like, if you settle at a bad price, like, that's the user's problem, not maker's problem. So there is this. This is one of the bad sides. I'll talk about in a second. And this is basically equivalent to routing on indicative quotes. There is a crucial component for these propAMMs. Most of them, they quote something, but it might happen that they do not land the update. I don't know, whatever. System goes down. They don't want to send updates. The price then gets worse. So it's a win-win for the operator. If they manage to update the price at the beginning of the block, it's nice. You trade against the price that they just posted. They're happy with it. If you somehow trade before they publish an update, you are getting a price which is 1 block stale, and there is a penalty for it. So if the volatility is too high, they just stop quoting. Very convenient and very practical for them. And this is a very good tool for fighting toxic flow. You refresh the price, great. I mean, this means it's a price you're willing to trade at. If someone front runs you, it means they landed before your update, and they get a penalty for this because the time has passed between the updates. Why they're bad? There are many issues with them, and it's not even necessarily malicious stuff. It's just the design. It poses some challenges. So they're black boxes. You don't see the code. I mean, it's not in market makers' best interest to show their code and so others can see how they're quote. They will instantly get ARBed. So you can either decompile the code, or you can try to find out who that is and ask nicely for an SDK. They all have whitelists, so you cannot. If you're a random person that tries to make a swap on your own, you're probably not gonna succeed. You need to be whitelisted. All popular routers are whitelisted. They can misbehave in various ways. They get paused randomly. Like Uniswap pool cannot get paused. propAMMs get paused all the time. They give you some data that doesn't match reality. They publish curves which are weird or behave in a way you would not expect. Sometimes they give you SDKs do not match reality. There are some weird gotchas that they will not talk about. There is a lot of room for bad behavior. And Base introduced flash blocks in 2025, effectively cutting the block time from 2 seconds to 200 milliseconds. And while 2 seconds is fairly slow, 200 milliseconds is something one can work with. So the fees are cheap on Base. There is priority fee sequencing, so you basically can guarantee high positions in the flash block if you raise the priority fee, which is fairly convenient for propAMMs, and they instantly showed up on Base. There are already around 10 of them, and they drive around half of our swap API volume on ETH to USDC. So they're definitely picking up steam, and they are having a good time. We've been researching this execution quality for quite a while. That's me on that photo. That's I didn't choose it. It just happened. That's from 4 years ago at DevConnect. We were looking into slippage on dexes. Nobody even was looking at these things at the time. Now it's kind of standard. And we also looked at execution quality of our propAMMs. And there are some bad things happening, that if you do not stare and analyze the data, you will get hurt. This behavior I'm talking about right now, we can more or less get rid of it, but early it was happening. And the core issue is that the aggregator sees the state at the end of the block. And what would your market maker do? They would publish in the last flash block, the green one, they would publish a very good price. You see it, you route on this, and then someone is trying to settle. However, in the first flash block of the next block, with higher priority fee, they will publish a price update which will make the price bad. So for vast majority of the block, the price is bad. At the very end, they make the price good. You route on this, you send them flow, and they instantly make the price bad. So the price you see as the real prices are not really the prices you will see. You will obtain at settlement, because they turn off the good price instantly at the beginning of the next block. And you can see that, for example, it was an example of a propAMM that we had to turn off for this behavior in January, I believe. So the price moving between blocks was 1 basis point, but inside the block, it was 8 basis points. This should not be the case, because between blocks, there is more time than inside the block. Yeah, they were basically spoofing the router. Another thing that they do, another example, is that they will have multiple pools, and the price movements between them will not correlate. So they will have 4 pools. 1 pool will always have a very good price. They rotate, and it's like pool A has a good price right now, but worst price in block n+1 and n+2 and n+3, and then it has a good price and a bad price, and they just rotate. So there's always 1 pool which has a good price, which is winning the flow. But when the transactions land, most of the time they'll hit the bad price. It's very hard to prove that people are doing this on purpose. So let's call it a working theory. But on Solana, there are propAMMs that have pools where price movements are not perfectly correlated. There are also propAMMs on Solana which have multiple pools, and the price movements are perfectly correlated. So that's suspicious. And why this phenomenon persists? It's a very weird. It's a dilemma that we have here. So if you have an aggregator that tolerates these predatory sources, it can show users better quotes. So their competitors, they have a choice. Either you lose order flow to someone who shows better prices, or you have to do it yourself. So either all aggregators have to police this bad behavior, or the one that keeps them will win majority, unless there is a movement and some, for example, social backlash that, hey, this aggregator shows fake prices. Nobody's really checking these things. And this way, bad actors are pricing out good actors. Like we put effort into policing this stuff. Someone else doesn't. It's still happening on base. There are aggregators which will show you prices which are too good. So it's basically a do or die practice at this point. Policing is good, and it's necessary for the industry. If you're an aggregator, you definitely should look at your propAMMs and how they are filling their quotes. And just to wrap up, I think that propAMMs are here to stay. They're not going anywhere. Every good market maker, we know every single one at this point, they already have or they're launching soon a propAMM on Solana. Competent market makers are launching propAMMs on Base. We are talking to them constantly. We have, even today, I had one reaching out about prop being integrated on Base. They will continue to exist on every fast chain. There are propAMMs on BSC, on Monad, on Arbitrum. Every EVM chain that's not mainnet will have propAMMs. They are trivially composable with traditional AMM liquidity. This literally lives on chain. For transaction settlement, it looks like a DEX. It's very easy to interact with it, and it will progressively render RFQ irrelevant on majority of blue chip pairs, since the propAMMs don't need to sit on a quote. They can offer much tighter spreads, while RFQ needs to hedge for volatility. They have to widen the spreads, immediately worse pricing. And they are also coming to Ethereum. It's a bit heavier lift. I think Titan just announced that they will be accommodating some of the propAMMs in their blocks, because it requires the block builders to cooperate. They have to make sure that the price updates from propAMMs are at the top of each block. And also there are many builders on Ethereum, and you need basically every single one or a vast majority of these builders to engage in this practice in order to have good coverage. You cannot have the case where 50% of the time your transaction will execute properly and 50% of the time it will not. However, again, I expect this trend to continue, and it will be probably in the high 80s or at 90%. It's a matter of months, because it's clearly an improvement to our old DEX model. All right, that's it from me. Thank you.